A sequence is a set of numbers that is defined by rule. So this would be sequence right here, 3, 7, 11, 15. And the rule is that you add for each time. And one in arithmetic sequences is a sequence, and where the rule is that you add a number to a number each time. So like you add 4 to this, which would be arithmetic. And if you have a sequence that's like 0, 2, 4, 6, this would also be arithmetic because you add 2 to each term each time. Now, this would be a finite sequence because it ends after you reach the number 15. But if it kept going, 3, 7, 11, 15, and 19, and so on, this would be called an infinite sequence. So there are two types of sequences, which are finite sequences and infinite sequences. And there are a lot of ways to define a sequence, one of which is what I did here, is just writing out the numbers separated by commas, 3, 7, 11, 15, 19, and so on. And another way to do it is to write the explicit formula, which is like this. U of n equals an plus b. And this takes the position of a number, which is n, and you can plug it into this formula to find the number inside that position. For example, u of 1, we're looking at the first term of the sequence, and that here is just 3. And u2, that means the second term, so that's 7, and so on. u3 would be 11. Now, what do the variables a and b mean? A is the difference between each number in the sequence. So here it would be 4 because 7 minus 3 is 4, 11 minus 7 is 4, so on. So let's write the explicit formula for this sequence. Un equals 4n, and we have to have a plus b. And how do we find b? Well, if we know what n is, and we know what a term is in that position, we can just plug n into this equation to find b. What I mean by that is, if we have u of 2 equals 4n plus b, and u of 2 equals 7, we already know that. We already know n is 2 because we replaced the n right here with 2. So let's replace n with 2. And now we can just replace this u2 with 4 times 2 plus b because they're the same. 4, 2 plus b equals 7. We have 8 plus b equals 7, which means b equals negative 1. So this is going to be our explicit formula for this sequence, 4n minus 1. And we can test it for first term as well. U of 1 equals 4 times 1 minus 1, which is 3. We can test that for the third term. U of 3 equals 4 times 3 minus 1, which is 11. And another way to define a sequence is by using the recurrence formula, which is kind of simple compared to the explicit formula. And it goes like this. So first, you need to know what the first term is. And for the recurrence formula, you just write it out. U1 equals 3 in our case. If the first term was 2, you just write U1 equals 2. And now, you need to write UN is equal to UN minus 1 plus whatever the difference between the numbers is. So this would be 4. So plus 4 such that n is greater than 1. Now, how does this work? So if n is 1, which means you're looking at the first term, you just look here. U of 1 equals 3. So you know the first term is 3. But if n is 2, or 3 or 4, or bigger than 1, then you look here to this formula, because you're looking at any number other than the first term. So if you are looking at the second term, u2 equals u2 minus 1 plus 4, and 2 minus 1 is just 1. And u of 1 is just 3. So 3 plus 4 is 7. So we know u2 is 7. And we can just keep moving on. u3 equals u3 minus 1 plus 4, which is u2 plus 4. And we already knew u2 is 7. 7 plus 4 is 11. And you can just keep going. But the problem is, if you don't know each number in between, you the first term, you're trying to find the 15th term. You need to find u14 because you do u15 equals u14 plus 4. You need to find u14, so you do this equals u13 plus 4. You have to keep going on and on. So it's really intuitive, but also it's not as practical as using the explicit formula, because you have to find every single formula, every single term in between the terms that you're looking for. Now, let's start with some practice problems. This one says, find the 25th term of 2, 7, 12, 17, and so on. If you think you can do this one by yourself, pause the video and try it. But I'll explain it right now. So, to find the 25th term, we can write explicit formula, recursive formula, whatever formula you want. But I'm going to use the explicit formula. Let's write it un equals, the difference is 5, so 5 n 5n times 1 is 5, minus 3 is 2, so minus 3. This is going to be our explicit formula. So, to find the 25th term, we just plug 25 in for n. So u of 25 is equal to 5 times 25 minus 3, which is equal to 125 minus 3 is equal to 122. This is the 25th term. Pretty simple. Here's another practice problem. It's a little harder than the last one, but if you think you can do it, pause the video and try it. So, for this problem, you were given two terms in the sequence. You're asked to find the first term of the sequence. So here, we have u of 7, u of 13. We can use these two terms to find the difference between each term. Now, the difference between 7 and 13 is 6, and so for 6 terms, it goes up by this much. The difference between 41 and 77, which is 77 minus 41 equals 36. So every 6 terms, the sequence goes up by 36. So how do we find how much it goes up by? If it goes up by one term, we just do 36 over 6, which is 6. So that means the difference between each term is 6. Now, we can just count backwards from 7 now. So since we know that the difference between each term is 6, that means we know that u of 6 equals 41 minus 6, 35. u5 equals 29. u4 equals 23. u3 equals 17. u2 equals 11. And then finally, u1 is equal to 5. This is our answer. And what we did is find the difference between the two terms, like their position in the sequence, and the difference between the values of the two terms, which is 41 and 77. And we use those numbers to find the difference between each term in the sequence. And then after we found out that difference, we counted backwards from 7, going to the 6th term, 5th term, and so on until we reach the first term. And our value is 5. And here is another practice problem. This one is also kind of challenging and it's a bit different from what we've done earlier. But if you think you can still do it, then pause the video and try it for yourself. But this is a consecutive arithmetic sequence. These are the terms as the question tells us. And this means that the difference between each term is going to be the same, which means that x minus 2, this is the difference between these two terms, x minus 2 and x. The difference between them, which I've written here, is going to be equal to the difference between these two terms, because it goes up by the same amount every single time. So x minus 2 is equal to x squared minus x. And let's simplify this. X minus x plus 2 equal to x squared minus x. 2 equals x squared minus x. 0 equals x squared minus x minus 2. And we have a quadratic here, so let's factor it. This is pretty easy to factor. X minus 2 plus 1. And so we get x equals 2 and negative 1. And let's plug in these values to make sure they work. So let's plug in 2. X minus 2 is 0, 2, x squared is 4. So 0, 2, and 4. So that works. Negative 1, let's see if that works. Negative 3, which is negative 1 minus 2. Negative 3, negative 1, and negative 1 squared is 1. So negative 3, negative 1, and 1. This works because it goes up by 2 every single time. So these are our two values that work for this problem. And that is the answer. So everything that it does explain and all the problems that I went through is everything that you need to know for the basics of arithmetic sequences. And there's another type of sequence called geometric sequences, which we will talk about in the future. But for now, we are just focusing on arithmetic sequences, and this video teaches everything that you need to know about them. So, if you learned something from this video, or you enjoyed it, consider liking or subscribing. It helps us a lot.